The Acids and Bases simulation is an innovative educational tool designed to help students understand the properties of acids and bases through an interactive and engaging context. This simulation allows students to explore the differences between strong versus weak and concentrated versus dilute acidic or basic solutions using particulate level diagrams, graphs, and tools such as a pH meter, pH paper, and a conductivity tester. By providing a visual and hands-on approach, the simulation enhances students' understanding of these fundamental chemical concepts. This simulation focuses on the chemical properties of acids and bases and their behavior in solutions. It illustrates how the concentration and strength of acids and bases affect their properties and interactions. The simulation includes various tools and visual aids to help students explore these concepts in depth. Key components of the simulation: 1. Particulate level diagrams. The simulation includes particulate level diagrams that show the molecular and ionic interactions in acidic and basic solutions. These diagrams help students visualize the dissociation of acids and bases into ions and understand the chemical processes at the molecular level. 2. pH meter. The pH meter is a tool used to measure the pH of solutions. Students can use the pH meter to determine the acidity or basicity of different solutions and observe how changes in concentration and strength affect the pH. 3. pH paper. The pH paper is another tool used to measure the pH of solutions. Students can dip the pH paper into different solutions and observe the color change, which indicates the pH level. This provides a visual and practical way to understand the concept of pH. 4. Conductivity tester. The conductivity tester is used to measure the electrical conductivity of solutions. Students can use this tool to explore the relationship between the concentration of ions in a solution and its ability to conduct electricity. This helps students understand the concept of ionic strength and its implications. 5. Graphs. The simulation includes graphs that display the relationship between the concentration of acids and bases and their properties, such as pH and conductivity. These graphs help students analyze and interpret data, reinforcing their understanding of the chemical principles. The Acids and Bases simulation provides a hands-on approach to exploring the properties of acids and bases. By creating solutions and using the provided tools, students can understand the following key concepts. 1. Strong versus weak acids and bases. Strong acids and bases completely dissociate into ions in water, while weak acids and bases only partially dissociate. Students can create solutions of strong and weak acids and bases and observe the differences in their properties using the particulate level diagrams and the pH meter. 2. Concentrated versus dilute solutions. Concentrated solutions have a higher concentration of acids or bases, while dilute solutions have a lower concentration. Students can create concentrated and dilute solutions and observe how the concentration affects the pH and conductivity of the solutions using the pH meter, pH paper, and conductivity tester. 3. pH and acidity or basicity. The pH of a solution indicates its acidity or basicity. Students can use the pH meter and pH paper to measure the pH of different solutions and understand the relationship between pH and the concentration of hydrogen ions, H+, or hydroxide ions, OH. 4. Conductivity and ionic strength. The electrical conductivity of a solution is related to the concentration of ions in the solution. Students can use the conductivity tester to measure the conductivity of different solutions and understand the relationship between ionic strength and conductivity. The Acids and Bases simulation offers several educational benefits. 1. Interactive learning. The simulation provides an interactive and engaging way to learn about acids and bases. Students can actively participate in the learning process by creating solutions, using tools, and observing the effects on the properties of the solutions. 2. Visualization of abstract concepts. The concepts of acids and bases can be abstract and difficult to understand. The simulation provides a visual and tangible representation of these concepts, making them more accessible and understandable. 3. Experimentation and exploration. Students can experiment with different concentrations and strengths of acids and bases and observe the resulting changes in properties. This exploratory approach encourages critical thinking and problem-solving skills. 4. Real-world application. The simulation provides a practical application of the principles of acids and bases, which are fundamental to many real-world phenomena. This helps students see the relevance of these concepts in everyday life. Number 5. Data collection and analysis. The simulation introduces students to the process of data collection and analysis. By using the pH meter, pH paper, and conductivity tester, students can collect data on the properties of different solutions and analyze the relationship between concentration, strength, pH, and conductivity.